Welcome to GMST Davangere. I am Anil Kumar TRV, Assistant Professor, Department of Electrical and Electronics Engineering. So today we are going to study the experiment number 9. So that is VV open delta for 3 single phase transformers in connection under the load conditions. So aim of the experiment is we have to make the comparisons and performance of 3 single phase transformers in VV connections under the load. Contents, these are the aim of the experiment, theory, apparatus required, circuit diagram, procedure, calculation and results. So apparatus we require here are 3 single phase transformers and 3 phase auto transformers and a multifunctioning meter, digital voltmeter, digital ammeter and some connecting wires. So when you talk about the theory, the concept of VV connection is also known as the open delta connections of a transformer, which is a method to connect the 2 single phase transformers to operate in a 3 phase systems when one transfer of the 3 phase delta connections becomes unavailable or is not required. So in normal delta connection, the 3 phase transformer connected in closed triangular configuration supplying a power to a 3 phase load. So if one of the transformer is removed due to fault, the remaining 2 transformers can still supply the 3 phase load using a open configurations, which resemble the shape of V. Hence it is connected. Hence it is named as a VV connection, or you can say open delta connection. So procedure: connections are made as shown in the circuit diagram. So with the 3-phase auto transformer, the minimum positions of the supply switch is closed using a 3-phase auto transformer and apply the rated voltage. So now transformer is loaded with a 3-phase resistive load. The load is increased step by step, and each step you have to take the readings of in the meters, and it has to be tabulated. So the load is removed step by step. The load is switched is open, then the 3-phase auto transformer voltage is reduced to 0 and supply switch is open. So this is actual circuit diagram. In this circuit diagram, this is your 3-phase auto transformers. Here we are using a W1, wattmeter 1, wattmeter 3, wattmeter 4, wattmeter 2. So this is the delta connections. Here all the 3 transformers are connected in the delta fashion, and this is connected to the resistive load. So this is actually tabular columns. We have to note down the readings of V1, I1, W1, W2, V2, I3, W3, W4, and we have to calculate the regulations and efficiency. So these comes under your calculation formulas. For efficiency, W3 plus W4 divided by W1 and W1 plus W2 into 100. For regulations, we have to use the E0 minus V divided by V into 100. Or you can say Vs no load minus Vs load divided by Vs no load into 100. That will give the regulations. And this is the finally the results. We are going to plot the percentage of efficiency versus the output in kilowatt. Thank you. So today we are going to learn the determinations of VV connections under the load. So we have to make the connection as per the given circuit diagrams. So after making the connections, we have to close the switch. So once we close the switch, we have to set the auto transformer to the 440 voltage on the primary side. You can see the voltage is 440 voltage. On the secondary side, it is 230 voltages. So now we have to vary the loads step by step. That is, we have to close the switch. So once we close the switch, then you have to take the readings. So this is V1 and this is V2. This is I1 and this is I2. So now this is W1, W2, W3 and W4. So now we have to take the reading. That is, V1 is 440 voltages, V2 is 230 voltages and V3 is 0.42. Next, W1 is 80 and W2 is 60, W3 is 120 and W4 is 120. So next we have to take the one more readings. So now W1 is V is 440, V2 is 228 and I1 is 0.71 and I4 is 1.16. W1 is 120, W2 is 120, W3 is 220 and W4 is 240. Next we have to apply the one more load. So once we apply one more load, we have to take the readings again. So V1 is 440 and V2 is 229. So I1 is 1.0. Next I4 is 1.73. So W1 is 180. So W2 is 180 and W3 is 320 and W4 is 340. So this is the multiplication factor, that is W constant is equal to Vi cos phi divided by 1500. So that is 600 into 5 into 1 divided by 1500. It will be W constant will be 2. Next for W3 and W4, Vi cos phi divided by 1500, that is 300 into 5 into 1 divided by 1500. So W constant will be, for W3 and W4 it is 1. Thank you.